Let's learn about synthetic division. For example, let's use synthetic division to divide 2x cubed minus 9x squared plus 6x minus 7 by x minus 4. Now, synthetic division is a shortcut used to divide a polynomial by x minus r. Notice here, this is a degree 1 polynomial. So synthetic division can only be used when the divisor is a degree 1 polynomial. And this technique comes from looking at the coefficients of p of x and the value of r. Now, what are the coefficients of p of x here? Well, let's put them under a division sign. We have 2, -9, 6, and -7. And it is imperative that our polynomial is in standard form before we read off these coefficients. But moreover, if there were any missing powers of x here, we'd have to write 0 for that power as a placeholder. Now, what is our r here? Our r is 4. So let's put the 4 to the left of the division symbol. Now that these numbers are set up, the first step in synthetic division is to drop the first coefficient of p, so we'll drop the 2. The next step is that we multiply the 4 and the 2 and put our result here, so 4 times 2 is 8. And then we add. So -9 plus 8 is -1. And now we continue this pattern. So we multiply the 4 and the -1, which gives us -4. Again, we're going to add, which gives us 2. And then we multiply, which gives us 8. And then we add, which gives us 1. Now, what are these numbers down here? These first 3 numbers are the coefficients of the quotient of the division. And this last number here is the remainder of the division. And moreover, the degree of this quotient is 1 less than the degree of our dividend p of x. And this is because our divisor, x minus r, is a degree 1 polynomial. And since our dividend here, p of x, is a degree 3 polynomial, then our quotient will be a degree 2 polynomial. Therefore, our quotient, which we'll call q of x, is equal to a degree 2 polynomial with these coefficients. Namely, it's 2x squared minus 1 times x plus 2. And our remainder is equal to 1. This number here, this last number. Therefore, by the division algorithm, p of x divided by x minus r is equal to q of x, which is 2x squared minus x plus 2, plus the remainder divided by the divisor, which is x minus 4 in this case. Let's actually take a quick look at the long division, so you can see why this technique works. So we'll be dividing p of x by x minus 4. Now x goes into 2x cubed 2x squared times, and 2x squared times x minus 4 is 2x cubed minus 8x squared. And now subtracting, we get negative x squared plus 6x minus 7. And x goes into negative x squared, negative x times. And negative x times x minus 4 is negative x squared plus 4x. And subtracting gives us 2x minus 7. And now x goes into 2x 2 times. And 2 times x minus 4 is 2x minus 8. And when we subtract, we get 1. So sure enough, our quotient is 2x squared minus x plus 2. And our remainder down here is 1. Now, sometimes students get confused that we subtract here, but we add with synthetic division. But notice here we have this negative in front of the 4, whereas with synthetic division, we don't. So subtracting then here will give us the same result as adding when we use synthetic division. All right, let's look at one more example. Let's use synthetic division to divide p of x by x plus 4. Now, the first thing to notice about p of x here is that it's not written in standard form. So let's do that. Let's write it in standard form. We have p of x is equal to, we have this x to the 4th term, so negative 2x to the 4th. And then we have this x cubed term, so negative 7x cubed. And then we have this x squared term, so plus 4x squared. And finally, we have this constant, plus 1. Now notice here that there is no x term. And with synthetic division, it's very important that we have every power of x. That is, before reading off the coefficients of p, we need to write p of x as follows. Negative 2x to the 4th minus 7x cubed plus 4x squared plus 0x. We have to have a placeholder, and then plus 1. Now we're ready to read off the coefficients of p. They're negative 2, negative 7, 4, 0, and 1. But what is r? We're dividing p by x plus 4. And we can think of x plus 4 as x minus a minus 4. So this is r here. So let's put the minus 4 here. And now we drop. We multiply, which gives us 8. Then we add, which gives us 1. Then we multiply the negative 4 and the 1, which gives us negative 4. And then we add, which gives us 0. And then negative 4 times 0 is 0. We add, we get 0 again. And negative 4 times 0 is 0. We add, we get 1. Now remember, these are the coefficients of our quotient. But moreover, our quotient is 1 less in degree than this dividend here, p of x, which is of degree 4. Which means q of x, then our quotient, is of degree 3 with these coefficients. Therefore, it is equal to negative 2x cubed plus 1x squared plus 0x plus 0, which we don't need to write. And this is our remainder, r of x. Therefore, by the division algorithm, we have that p of x divided by x minus r is equal to the quotient q of x plus the remainder r of x divided by x minus r. Or in our case, p of x is 1 plus 4x squared minus 2x to the 4th minus 7x cubed divided by x minus r, or x plus 4, is equal to q of x, which is negative 2x cubed plus x squared, plus the remainder of 1 divided by x plus 4. All right, and this is how we can use synthetic division to divide a polynomial by a divisor that is a degree 1 polynomial. Thank you, and we'll see you next time.